On this video, I like to talk about volume of a solid finding the volume of a solid using washer method. So let's say you have a bigger disk right here, and you have a smaller disk. The bigger disk has a radius of capital R, and smaller disk has a radius of small r. Now, again, the big R, capital R, is the distance from the axis of rotation to the outer curve, and small r is the distance from the axis of rotation to the inner curve. Now, let's say that you are from a bigger disk, you're taking away the smaller disk. So what you're going to have is a hole in the middle. A disk that has a hole in the middle, we call it a washer. And what will be the volume of this washer? Well, it's like finding the volume of a bigger disk and then take away the volume of a smaller disk. So if we say this is d of x, then the volume of a bigger disk will be pi, and the radius of a bigger disk will be capital R, so square times dx. That will be the volume of a bigger disk. Now, what about the volume of a smaller disk? Well, the volume of a smaller disk is small r, so it's going to be pi small r squared times dx. This is the volume of a washer. Now, if you take away the common factor, which will be pi dx, you're left with r squared capital R squared minus small r squared. And if you put it in this order, it will still be the same thing. Now, please remember this formula because we're going to use it again. So now let's say that you have a region bounded by the blue curve and the horizontal line, which is red, and the y-axis. So we're talking about this this region right here. Okay? This is the region that we're talking about. This area is bounded by some horizontal line, y equals certain number, constant, and some curve, y equals f of x, and it's going from 0, let's say A, to B. And this area is revolving about the x-axis. Okay? Now just imagine, if that region revolves about the x-axis, it's going to create something like solid that will look something like this. Okay? So now, if you get a cross section, let's say you cut this vertically and you get a cross section, what you're going to get is you're going to get a washer. You are going to get a washer. And there's going to be a hole in the middle. Okay? This is the x-axis. So, how are we going to find the volume of this solid? Well, what we're going to do is, just like what we did with the disk method, we are going to get a bunch of small washer. We're going to get a bunch of washers and add up the volume from A to B. So what we're going to do is, remember the formula that we talked about a few minutes ago? We got pi quantity r squared minus r squared quantity dx. What we're actually doing is we are finding the volume of a bigger disk, which is integral from A to B of pi big R squared dx, and we're going to subtract the volume of a smaller disk from A to B and I forgot the pi. And when you combine it, this is what you're going to get. Integral from A to B pi, integral from A to B, quantity big R squared minus small r squared times dx. So this is a formula to find the volume that involves washer. Again, what you need to do is you got to be careful that you need to remember that big R is from the axis rotation to the outer curve. That's the big R right there. And the small r is from the axis of rotation to the inner curve. Now let's take a look at an example. Let's say you have a region bounded by y equals radical x and y equals x squared. Well, they intersect at 0 and 1. And this region right here is revolving about y equals 1. Okay, 360 degrees. So when that region revolves about y equals 1, you are going to get a solid that kind of looks like this. And this is y equals 1. So axis of rotation is y equals 1. And when you get a cross section of this solid, you are going to get a washer. Okay? But that's y equals 1. And what is your big R? The big R is from axis of rotation, which is y equals 1, to the outer curve, which is to the blue line, blue curve. So your big R is going to be, 1 minus x squared. Can you guys see that? The big R is going to be 1 minus x squared. What about your small r? Your small r is going to be, again, the distance from the axis of rotation to the inner curve, which is the red curve. So it will be 1 minus radical x in this case. So the volume of the solid is going to be pi, integral from where to where? 0 to 1. What is your big R? quantity 1 minus x squared minus small r squared, which will be 1 minus radical x squared, that whole thing, times dx. So this right here would give you the volume of a solid. Now in this case, the same region will be revolving about y equals -1. So when that happens, you are now going to get a solid that kind of looks like this. Okay, now that will be y equals -1. Our axis of rotation now is y equals -1. So now, what is our big R? Our big R will be from y equals -1 to the outer curve. Okay? Now, what will be the distance of that? Well, that's going to be top minus the bottom, which will be radical x minus -1, which will be radical x plus 1. What about your small r? Your small r is axis of rotation to the inner curve, which will be x squared minus -1, which is x squared plus 1. So what will be the volume of the solid? Well, it's going to be pi integral. Again, we're going from 0 to 1. And big R, which is quantity radical x plus 1 squared minus small r squared, which is quantity x squared plus 1 squared, all of that times dx. Now again, you may use your calculator to find the answer, but this is a setup that you need to find the volume of the desired solid.